better yet, to take those planets or images of them and go outside and arrange them on the same scale. I mean, it's a phenomenal experience, in my opinion. So I'm going to talk a little bit about the essentials of how we do it. I'm going to show you a PowerPoint of some kids actually doing the lesson, and then we'll go on from there. When we do this in Saturday Morning Astro, I've also done this with some teachers at schools, and we like to have the kids work as a team. So we'll do this in groups of 4 as a minimum, probably 5, 6 students per group. The materials that you have that we sent you would accommodate probably 3 groups. And if you have, 8 kids in a group, that's fine too. There are different ways to do this, and I'll go into that here in a little bit to engage every student as part of the lesson. So with that, we have a description. Bill sent the list of the materials you need. Some of you that registered in the group of First 25 received the materials. Before I go any further, I'm just going to ask, does anybody have any questions about the materials required or the materials you need? Any questions at all? Who's got a question about items you have or things you need? You may think of things as we go along, and that's fine. You can raise your hand, put a question in the chat, and we'll address them. But I just wanted to give you the opportunity now. I also want to tell you, I apologize for my appearance. I'm undergoing a skin treatment, and I kind of look like Phantom of the Opera, and I apologize for that. But it is what it is, and so take me as I am. I'm going to go to the PowerPoint next. So I'm going to share my screen. And Bill, while I'm in the PowerPoint, if any questions come up, please let me know, okay?
Will do, David.
Okay. Bill, can you see that okay?
Yes.
Okay. So here's an example of a model from a textbook. We see the sun, we see the planets. It's colorful. The planets look reasonably good in terms of size. However, the distance between them is impossible to do on a single diagram. So that's one of the limitations that I referred to. So when we start this lesson, we have the kids make, using the Exploratorium website, and if you looked at the lesson, that's the link there is in the lesson. We start by a scale balloon. And so we blow up a balloon to somewhere between 9 and 10, 11 inches. Bear in mind, the larger your balloon, the larger the planets, which is convenient, but also the greater the distance between them. So if you have a balloon that's 14 inches, you're going to be going half a mile to make this work. So you'll have to tailor it to suit your own needs. But we've done this with 5th graders. We've done it with high school kids. Depending on the resources and the way the teacher wants to do it, there are different ways. So, for example, we need to know the diameter of the balloon. You saw in the video a couple of students measuring the diameter. It was with a string. It was a little cumbersome. They removed the string, and I probably, for some of the younger kids, if they want to take a ruler and eyeball the diameter, that's okay. Everything will be to scale. More accurately, if you want to wrap a string around the balloon, mark it before you take it off the balloon and measure it and go from there. There are a couple of tables that I'll go over. Right now, I'll just say if the first data table the kids will fill out will be the diameters of the planets. Now, we measure, when you go to the Exploratorium website, for convenience, we measure the diameter of the circumference and the diameter of the sun, calculate the diameter in inches. You could do it in other units, but inches are convenient again, for convenience. Instead of doing inches for the diameters of the planets, we use millimeters. And so based on the scales that we typically do, the Earth is going to be, about 3 millimeters. Jupiter might be, about 25 millimeters. So that's quite a range. And I'll show you examples of those here in a short while. I'll also talk about stepping off the distance. And some of you may have questions about how to do that. And we'll get to that here in a short while. So here are a couple examples of kids making their planets. We found out early not to give kids a whole lot of freedom and a whole lot of time, because they can spend half an hour making 8 planets. And I would try to have them do that in about 10 minutes, because otherwise it just takes too much time, unless you have the time to do that. That's up to you. But when we do this here on campus, or if I take materials to a classroom, we have the kids put their planets in a little cup. In the video, I showed you another way to do that, and that's just to have the printed sheet, and kids can tape their planets on the printed sheet, and they have them all in one place, and it's good for comparison. So there's the printed sheet, so they can tape their planet in place right in the diameter, and they can see then firsthand the difference in size. Next, we'll go out in the hallway or outside. We'll mark off 50 feet, and we will have the kids, each student in each team, every student does the stepping. They'll count the number of steps in 50 feet. You could use 100 feet, you could use 20 feet. It's an arbitrary thing. That's up to you. But when they take their planets or images of the planets outside and put them in order to scale, we'd like every kid to step that off. It gives the kids a chance to compare and take an average of everyone's steps as they go along and agree on where the planet goes. So they will do that 3 times, take an average, and then use that to calculate. So, for example, if the distance to Mars is on this scale 34 feet, they need to know how many steps 34 feet is, so they can calculate that. Then once we get outside, the kids will set up their planets according to the distance between them. Now, we use we sent you some landscape stakes. That's fine. Take a hammer, pound the landscape stake into the ground, and there's, I would take like a little binder clip, rubber band it to the stake. You have images of the planets, so cut out the images, clip the image to the stake, and you can see at a glance where the planets will be. So in this picture, the girl standing here with the orange balloon, that's the sun. And the first planet is, if you can see my cursor, right about here. So there's Mercury and Venus and Earth. And so the first 4 planets are roughly about 30 feet apart, depending on the size of your sun. So, 120 feet and you're at Mars. The distance between Mars and Jupiter is 5 times that. So it's just phenomenal to see the expanse between the inner planets and the outer planets. So this is the really exciting part of this experiment. I've got some comments from some of the kids that have done this. They're always amazed at how insignificant the Earth and humans are compared to the rest of the solar system, not to mention the cosmos. A couple of things that I would highlight briefly before we go on in terms of classroom management. I mentioned not to spend a lot of time making the clay models. When I do this, I'll get the kids started, and after about 5 minutes, I'll say, okay, you got 4 minutes left, and kind of count down so that they stay on task. And it's nice to be artistic. I like that. But if our objective is to get the planets and go outside, and usually time is limited, I try to speed that up as much as I can. Kids will try to be too accurate in stepping off the distances, and the nearest foot is fine. They don't have to go crazy with accuracy. In the big scale of things, approximations are fine. One of the things that when I do this on campus, or when I go to a school and do it, I have volunteers. I have plenty of volunteers, so I can assign a worker, a volunteer, a student to each of the student groups. Supervision is important. And so, we've done this at a school where the teacher brought in parents, and parents supervised. Grandparents have a blast at this. Grandparents have never done anything like this. So, they're always intrigued. And, I think about safety, think about where the kids are going, where they will end up. I will tell you, every time I do this, even on campus, I always think about a better place to do it. And I go out and I know I'm going to need about a quarter of a mile, 12, 13, 1,400 feet. And I'll step it off in various directions to know where to start and where to end up. Last couple of things. Kids are going to work at, the student teams will work at different rates. So some will finish sooner than others. Have a clear plan of where they're going outside. I usually draw a map, and I give each team a copy of the map where they will be stepping off relative to their surroundings. They know where to go, they know what to follow, and it alleviates having questions come up and problems later. I encourage them to stay together as a group, and whoever is monitoring the group can make that happen. A real important thing, and again, we learn by experience, and I discovered this early on, kids are going to finish and come back to the classroom at different times. Have the next thing ready for them. So that could be doing some calculations. It could be another activity. It could be writing a report or entering in a journal. Whatever it is, make sure that when they come back into the classroom, they know what to do so they can put down the materials and go to the next step. We had chaos a couple of times, and so I'm sure some of you can relate to that. Sometimes we do AUs, and so we have students, and this is in the written instructions. I won't go into this in detail. It may not be appropriate for your grade level, but if you like the idea of using another unit, we can step off. Instead of measuring in feet between the planets, we can measure in AUs, and students can calculate the number of steps in an AU, an astronomical unit. So the Earth would be 1 AU, the inner planets something less than that, and the outer planets a lot more than that. So that's an option if you like to do that. Bill, are there any questions that have come up yet?
Not yet, David.
Okay. One of the things I want to talk about is assessment, and we'll come back to this, but I am interested to know what your objectives would be for doing this in your classroom and how you might assess student learning. So we've come up with a couple of things along the way. Here's one example of, we do this as a pre and post, actually. So we have the kids draw just the relative size of the planets in each square. So they make up a size for the sun, and they scale the other planets accordingly. The results are interesting. I'm sure you might guess. Even more interesting is on the second question, given where the sun is at the arrow on the line, we have the students mark not by size, just by distance, the distance between the planets. And, you know, we'll get in a pre-test and a pre-quiz before instruction, we'll get students who will just distribute the planets equally. And, you know, and every other possible thing you can think of, none of which are accurate. So that's one thing you can use. This is all of the materials that I'm going to talk about are in the Google Drive folder for the sixth graders, sixth grade teachers. So all of this stuff is there in addition to a few other things. So here are just some photos of, in general, of kids doing this lesson and some of my volunteer teams. I'm going to throw out an invitation for you to become part of the Purdue team. So let's have a competition. Any teachers in the group who would like to share what they do with us in the way of a video, some photographs of their students doing this activity, let's have a competition. And let's look at the submissions we get, and I will pick 2 winning entries, and the teacher will receive a Purdue Physics and Astronomy t-shirt and a Purdue Physics and Astronomy sticker for every student in their class. So how's that for an invitation? Now, I recognize that, you know, you may not do this in the fall, you may do it in the spring. That's fine. We can, if you have a plan, let me know what your plan is. I would like to wrap up the competition by the end of the year if we can. So that gives you from now until the end of the first semester. And assuming that if you're going to do this outside, you probably need to do it before November. Let's say December 1st will be our deadline to get your entries in to be part of the Purdue team. And when I say part of the Purdue team, that means I could promote what you did on our website. And so that's what I would like to do. I would like to have you as the teacher and your students appear on our website as having done this lesson. Now it's going to require a consent form, and the consent form is also in the Google Drive. So if you have any questions about that, we can talk further. My contact information is already available to you. I'm going to ask you to do a survey at the end of our presentation, just to get some feedback on how we might better serve you. We've also got a Saturday Morning Astro at Purdue YouTube channel, and you can follow us on Twitter. So there's my promo pitch for the event. And with that, I'll stop sharing.
Okay, David, we have a question.
Okay.
Have you ever had the kids add the moons to the planets? I know it may not go with scaling, but it may be cool for the students to see.
In fact, that's a good question. I have an activity called 50 Balls of Clay. It's an activity with the Earth and the Moon. And what the students will do is take, just take I might have one here, a ball of Play-Doh. And if you take a ball of Play-Doh, and I have a video of this, I can tell you where to find it. Students will take the ball of Play-Doh and break it up into 50, as close as possible, same size pieces, 50 pieces. They'll roll them into a ball. So have 50 balls of Play-Doh on their table. They'll take one of them and set it aside, take the other 49 and recombine them. That gives them a reasonably accurate scale model of the moon and the Earth. So 1 to 49 in terms of volume. So they get firsthand experience then making the two and seeing how they compare. Then they will give them the distance between the Earth and the Moon based on the size of their I forget which it is, of the Earth or Moon, and we'll tell them the distance based on the size of the Moon. They can calculate that out and then distribute, set them out on the table distance-wise. So they have a good model of Earth, Moon, and the distance between them. Now, I precede this by having the kids do it as a pre-instructional quiz. I'll just say, take the ball of clay, separate it into Earth and Moon, relative size that you think is accurate, set them on the table, and how far apart you think they might be. And they do. And it always fits on a 4-foot table. And then they do it to scale, and 4-foot table is about 5 times too short. So it's a real cool experiment. And it's something that, we've done with middle school kids, elementary kids, even 9th graders or high school kids. So as far as the other planets and other moons, it's an interesting topic because you might ask how many moons the Earth has. We assume it has 1 moon, but there are other things out there that you might call moons. And so, the more we find out about things in our solar system, the broader the definitions become. And so Jupiter, for example, has some major moons that we're familiar with, but Jupiter has something like 65 moons or something like that. I mean, there's a phenomenal amount of stuff out there. I think that's a whole nother lesson. I think you could develop that. And if you're interested in doing that, I'd be interested in working with you. So that said, if any of you, have an idea, would like to pursue it, work on it with me, I'm happy to throw in my 2 cents and work alongside you. So I'm here as your resource. That's what we do in outreach.
We got another question, David.
Okay.
What suggestion do you have if you don't have enough room on your school campus? Like they have no sidewalks and too busy of country roads?
That's a good question. So would it be possible to do this as a field trip? I taught high school for 20 years before I came to Purdue 10 years ago. And, at that time we could plan a field trip. And I don't know how possible that is anymore. I mean, not aside from COVID and all of that business, would it be possible to do a field trip? Is there a park nearby? Could it be something that you could invite your students to do? I hate to say to invite them to do it as an out-of-class activity because that would not include everyone, and someone would be left out, and that's not a good idea. But another option might be have the kids go ahead and make the planets, and they can have the experience of making the planets, and then in as large a space as you have, you have the images that we sent you, the sun and the planets. Rather than do it in full scale, do it in a different scale. I think that's, not that, I don't think that diminishes the value of the activity that much. To say, okay, now we have the planets to scale. So you've seen this already. Here are the planets to scale. Now, let's just switch scales and see how far apart they are on a scale that we can accommodate. And so if you could go out in the hallway, you could have, could you have 50 feet in a hallway, 100 feet in a hallway? And you can't pound your landscape things in the ground. However, we've had students do, when they don't have a marker, they use like a 2-liter bottle filled with colored water. So, you could make them different colors, whatever, be creative. The Earth can be blue, Mars can be red, Jupiter can be whatever. So use 2-liter bottles. You could tape your image to the 2-liter bottle. And kids can still get an idea for the vast difference between the inner planets and the outer planets, and and how insignificant we really are. So how does that sound? Is that maybe an option?
They're I know you're not be able to read the chat as they're doing it, but they're given all kinds of great ideas. And I think they talked about whether they do it on a football field, the gym, the hallway. Someone said they scaled it down to the hallway. It works pretty well. They end up being about 6 feet apart at the beginning. So I think they're getting, and then thank you all for piping in. This is what we want to have happen.
Exactly. Our best ideas come from teachers. So, we have a beginning, but you guys do the finish. You put the polish on it. On the subject of, the images that we sent you, I don't think I sent you an image that I probably should, and I'll put it in the drive. So the images that I put in the Google Drive, I've got 2 different versions of each of the planets and the sun. And if you need a different format, let me know and I can accommodate you. We print these on, 36-inch and 42-inch paper. Now, you're not going to be able to do that, but Staples can, or if you want copies or a way to do it yourself in addition to the ones that we sent you, if we sent you any, or if you don't have the images and want to be able to print them, I can come up with whatever format you need to be able to print them yourself. We did this workshop with some teachers in the spring, and so the subject of, it always comes up, why don't you include Pluto? And, there are reasons that you might know, but we decided to have a little fun with that. And so if you want to use Pluto, I have Pluto just for you. So if you want to have some fun, do your kids even know who Pluto is anymore? I have no idea, but we do. And so if you want Pluto, I'll put Pluto in the drive as well. Okay, let's see. What did I leave out? Anything? Couple of things. Again, if you have questions, just pipe up and I'll try to answer them. I put a plan in the drive for the stands that we use here at Purdue, and so I think the markers, the landscape markers work really well. If you do this once a year, you don't need to be too elaborate. The markers are fine if you want to use 2-liter bottles or whatever. Traffic cones, some of the other ideas that you've come up with. We do this a lot. So I created this, the Planet Stand. It's a PVC base. We make these, we fill it with sand for ballast so they don't tip over, squirt a little insulation in there so sand doesn't leak out, and they come apart. And so, these are practical for us because we do it a lot. If you do this, if you find that you're doing this every year, and you are like me and want to just kind of, do something building wise, that's an option. When we do this, in fact, when we use this Planet Stand, I don't have one of the cups with me. I got some little shot glasses, glued a wooden dowel on the end, so the kids can actually take their planet, put it in the shot glass, stick it in the thing when they go outside, and they actually have their planet with them. In addition to we clip the image. So in one of the pictures you saw the kids with something like this. The shot glasses go in here. They take this outside, and then they have their actual planets with them. So that's probably extreme for what most of you would do. But if you want to be fancy, you could do something like that. I want to. Any other questions, Bill?
No, just a lot of comments, David, which has been good comments.
Okay.
There was a comment that they ran the activity with neighborhood kids, and it ranged from 4th grade to high school, and they all loved it. And once again, the misconceptions about the size and the distance were amazing.
I love it. I will enjoy reading these comments later because I'm real interested in what you have to say. I'm quite excited to hear those things.
And the other one said, I think putting the models on top of the garden stakes, it might help students to understand why we can't see the planets, but we can see the moon and the sun.
Exactly. So, having, if the kids can, I mean, even with the garden stake. So if you take the garden stake, you can clip so I just have a clip and a rubber band. I think I showed that in the video. You could take tape and just tape your planet on top and take it outside and have the planet as well. When you look at the distance, I mean, if you are a quarter of a mile, 1,200 feet from the sun at the end of the solar system, or even 100 feet from the sun as the Earth. So you look at the size of the Earth and think about the sun. The sun, this little tiny Earth, and they're 100 feet apart. That's mind-boggling to me. So, and it's mind-boggling to the kids too. It's a great learning experience.
Okay, hang on one second. I want to answer a quick. So I mentioned at the beginning that if you want CRUs or continuing education credits or whatever they're called in your state, all you need to do is email me. My email was at the very beginning, wbailey@purdue.edu, and give me the last 4 of your SOCH, and I will get you back the certificate with that. Yes, you need to email me after each session because I put these into different folders, and then that way I send one for each. And I may combine them this year, but that way I keep track and I know for sure that I've got everybody covered. So yes, I would like an email each time, please.
Bill, I've got a question about those continuing education units. Can we provide, is our certificate good in other states?
I have no idea. I assume that they are. Someone from another state would have to tell me if they've done it from outside the state. I would assume that they are. They're just showing that they had contact hours with us. And according to the state of Indiana, I'm certified to give those. So,
Okay.
I mean, we are Purdue University, David.
I believe all higher education institutions fall into the category of being
okay,
certified to do that.
We just got confirmation. Someone from Ohio said they were able to use it last year. So
Okay.
All right.
Okay. I want to move on here to something else. And before I do, I just want to say, doing this scaling our solar system, it's okay if you don't go all the way. Back to the question of somebody who doesn't have enough room. You don't have to go. When we do this, even on, we got a lot of space at Purdue, and we have multiple places where I can walk out 1,200 feet. However, there are sometimes complications. So we might walk 800 feet in one direction and have to take a dog leg just because the kids run out of space. And so it's okay not to go all the way. You probably are not going all the way. In fact, we never go all the way. We get about as far as Saturn, and we have no more room, and we don't have any more time. So if you have the room and the time, fine, you can go all the way to Neptune and Uranus. But probably you won't have that much space, and that's fine. So we don't have to be in a straight line. We can dogleg one way or the other, and it's fine to get to Jupiter and Saturn and call it good. And it's still a good learning experience. And then you come back to the classroom and you can talk about what's beyond. I am back to assessment. I am big on finding alternate ways of assessment beyond multiple choice and fill in the blank and even short answer. I like to think about ways that kids can express what they have learned in alternate ways. I like drawing. I like modeling of various kinds. So if you have ways that you have thought of or have assessed this kind of an activity, I'd be very interested in hearing them, seeing them, and sharing them with other people. So I would like to I'd like to think that we can keep our little group, our little family here together long enough that we can get some feedback from each other. And I am real happy to reconvene this group, not only to recap this activity, but to explore other things that you might do. For example, the 50 balls of clay. I hope we can stay in touch and do those things.
And David, I added your email into the chat because people were asking where they would send their videos if they did this lesson. And so I gave them your email, so they have that as well.
Okay, that is great. I have actually something that I'm going to pop into the chat as well. Let me just get it here. I created a little survey just to get some feedback from number one, the lesson, number two, this event. So I'm going to just throw that into the chat. If this is just a Google Forms to collect some feedback from you, whether you did the lesson or not, whether you will do it. I think I'm interested in your feedback. It'll help us in what we do in future workshops and tell us how we might be able to improve what we have already. So I would really appreciate having your feedback. It's a form that you can, if you change your mind and think of something else, you can go back and edit your form. So that is there for you.
David, couple things came up. Could be fun to have an interactive addition to a hike. Students could set up stakes or do something more permanent for others to join on the hike. That's a very interesting thing. If you worked with your local area and set something up like that, that might be something that gets some news media as well for you and your school. And then the other one was someone asked again about CRUs. All you need to do is send me an email. It's the very first email in this chat, wbailey@purdue.edu, with the last four of your SOC, and then I'll send you the CRUs at some point.
Okay, I'm going to.
And David, we have about 7 minutes left.
Yep, I'm going to use that 7 minutes. So the other experiment that we sent, first of all, the 50 balls of clay experiment is on my YouTube channel, the Physics and Astronomy YouTube channel. And I will give you the link for that. while I'm getting set up here. There are a lot of things. So this is the YouTube channel that started with Saturday Morning Astrophysics at Purdue, the SMAP program. Some of you are familiar with that. We're adding some things that are also just of general interest to science educators. So there you will find the 50 balls of clay. There's some things there with some lens and optics experiments. There's a real simple little activity on constellations called constellation tubes. So I'll let you look at that at your leisure. I have a little demonstration set up here, and I'm going to give you a view of what it looks like. The eclipses activity, the eclipses lesson. So if you receive the materials, you got some, or if you didn't, you will need some pearl head pins, a big balloon. When I do this on campus, I use a 60-inch balloon, which I never blow up to 60 inches because I can't get it through the door. But I blow it up to maybe 45, 48 inches, and I can squeeze it through a door to get it outside. The idea is, if your eyeball is the Earth, the pinhead is the moon, and for most kids, a reasonable arm length distance, the size proportion is about an arm length. So this is actually a little big, but the idea is the same. So the kids can have the moon, the Earth, and they figure out this distance and then scale that up to the distance where the sun would be. And so the sun is way out there. They back up, or move the sun to where it is eclipsed by the moon. And then that's the distance. And so it's kind of fun. Part of that lesson is why are sunsets red and why is the sky blue? So I have just a setup here. I have a mag light on a little stand. The stand was 3D printed by one of my students. I can put the file to print it yourself, and you can have your own. I can put that in the drive. And now I'm off screen and I can't see what I'm doing, but I think you'll be able to tell. The water represents the atmosphere. And so the flashlight, of course, is the sun. And I can see the light shining on the card from the sun through the atmosphere. And I'm going to add a drop of cream or milk. And I want you to look at the color change on the card. And I know the room lights are on. It might be a little hard to tell. I'm going to turn the room lights off. And the light coming through the water to the card is a lot more orange than it was before. So the blue light from the sun is all colors, the blue light is scattered by the atmosphere. So when the sun is overhead, what we see is the scattering of the blue light. The red light is more transmitted by the atmosphere. However, when the sun is low in the sky, the blue light, the effect of the blue light, blue light scattering is less than the effect of the red light coming through. So the longer wavelengths are transmitted. That's why the sky looks orange, red at sunset. So you can see this with this little demonstration. Now, it's really more dramatic if the room is dark and you can see the kids can watch it change color. I'm also going to show you, when you look through the tank, again, this is more evident if the sky or if the room is dark. The light will change color. The flashlight, the color of the light will be more blue closer to the light and more red further away. And so if you do this for yourself, you'll see it much better than you're going to see it here. But that's part of the lesson in eclipses. So Bill, how am I on time? 1 minute?
You got 1 minute.
Okay. Well, thank you all for joining us. Check us out in the future. Come back, say hello. Check us on the YouTube channel. Email me anytime, and let's talk more because I really want to hear from you. And I'm excited to hear that some of you might be sending some photos and video of your students doing this. I would love to feature that in Purdue